It's Code Everest time. Hey YouTube, it's Josh Feinstein with Code Everest. I'm super excited for part 3 of my JavaScript Enigma Machine. Why do you ask? Because I just uploaded part 2 and I was watching it just to critique my performance and see how I can improve this channel. And it hit me. Why was I getting an error? So in part 2, I was able to set up 6 configurations for the 3 spindles. I was also able to properly increment each spindle, but I was getting an issue where sometimes some of the results would be undefined, and it hit me. I was having a lot of trouble deciding if it should be modulus 26 or modulus 27. I'm thinking to myself, there's 26 letters, should be modulus 26, but wait, it's on the 27th letter that we go back to 0. Yeah, okay, that makes sense, but why am I getting undefined? My objects were not 0 indexed. So on 27, we would go to 0. But there is no 0 in my object. A was 1. So there are 26 characters, but there's no 0. And modulus is going to bring me back to 0. So what's the fix? I need to 0 index my spindles and my wire pairs. Let's take a look at some code. So let's look at this deeper. A is 1, and when I started out, it went 1 through 26. I need to set A to be 0, and I need Z to be 25. And then my modulus is going to be modulus 26. That's why I was having that weird issue in my brain, because it felt like it should be 26, because it should be 26, but then it felt like it should be 27, and I was getting very confused. So I'm going to rework all these to be 26s. And now the spindle counter 2, on the instance that it's 24, if it will increment spindle counter 1, and then it will make, it'll increment spindle counter 2, blah, 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 just like video 2. So the rotation point now is going to be 25, not 26. So when it becomes 25, when spindle counter 2 equals 24, then it's going to become 25. It's going to increment spindle counter 2 to become 25. That will increment spindle counter 3, so on and so forth. These should be 25s at our initial point. Oh yeah, if you look here at the bottom, we've got undefined here. That's why, because in that instance something was a 0 and there is no 0 in my cipher pairs here, whatever you want to call them. Also, between the last video and now, it was made clear to me by my brother, whose idea this was, that the Enigma machine didn't have spaces and it didn't have punctuation. Good reason for that. The reason for that is that common words like, well, it was German, but just doesn't matter. In English, words like words like the, at, very common, repeatedly used words would have signatures. If you have space, something space, you're always gonna, you can guess, oh, that might be the word and it might help you decode this message. So I'm going to pause the video. I'm going to decrement all the numbers in all of the spindles and wire pairs by 1 so that my letters are now 0 indexed. And I'm going to do some tests, and I believe that's going to solve the issue here. Once that's done, I'm going to make it so that when you input a string of characters, instead of getting an array of numbers, you're going to get back a string of characters, and that will be our functioning Enigma machine. So let's take a quick instant break via YouTube Magic. And we're back. All right, so I've decremented everything. You'll see here now in spindle C, for example, this is a 0. That's the lowest number. And where do we have our 25? That was previously a 26. Here, 25. So now everything is from 0 to 25, and now it's going to be modulus 26. So in our last test, I had run this and gotten some errors. Let's see what happens. Not errors, but I got undefined. I still get undefined. That boils me. Oh, that's awful. But this is set at 25 offset. Let's start this. Let's go a little lower. Nope. I spoke too soon. Got really excited. That was not the issue, unless there's a mistake elsewhere. So, All right, so now I'm going to have to do what I thought I was going to have to do all along, and that is do a real careful debugging of this super complicated machine. I was so excited that was going to help. So what happens here with our spindles 1, 2, and 3 in the case of, oh, this is too many. Let's lower this to 3 A's, make sure that everything's still working. So our first spindle goes up to 23. The next one stays at 24. Then it goes to 24. That stays at 24. It goes 25. That becomes 25. That becomes 1. Let's do one more. Now we should see spindle 25 and 1, 25 and 1, 25 and 0. Yep. So our spindle counters are working properly, modulus 26. So why am I getting that error? It's a good example of getting excited prematurely. I really thought that was going to be the issue. So what's undefined here? Let's see. How can we go about trying to figure out what the issue is? We keep adding A's. Figure out. All right. So it happens on the 5th. So what happens on the 5th time? The 5th A becomes undefined. So this becomes 23, 24, 25, 26 is 0, and then 1. This spindle goes up to 25. Oh, okay. I figured it out already. I fixed the fact that these numbers weren't 0 indexed. I did not fix the fact that these were not 0 indexed. So I'm going to move this 26 up to here. After all, the spindles are arbitrary as long as there's no duplicates, and there aren't. And each spindle is unique. So it was the same issue. I believe I was correct after all. I just didn't fully solve it because it happened in multiple places. So now let's run it again. Boom. Boom. Enigma. Let's put a whole bunch of letters in there. Let's see what we get. Nothing is undefined. Our machine works. Ooh, very exciting. Okay, so the only thing is that the Enigma machine wouldn't spit out numbers. So our coded message, first we're going to dot map it. We're going to take each element and I'm going to make a new object that basically goes from 0 to 25 and takes those numbers and turns them into the alphabet A through Z in order. So what should I call that? I'll just call it alphabet. So alphabet at the current element. And then we're going to do dot join. And that's going to put it into a final string. So the only thing left to do is to create our alphabet object. Put that right here. We're going to call this, we're going to call this alphabet. And then this is going to be A, B, get out of there. Oh, but these are strings. So this is going to be like this. A, B. Let's just delete all this stuff. I need that comma. Okay, go back up here. I could stop the video, but I feel like by the time I do that, I'll just be done. Okay, go back up. And then we've got C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. All right, I'm feeling cocky because I solved this issue that was plaguing me. There we have it. There we have it. So I'm going to do something here just for fun, and it's going to be we're going to make a const. We're going to call it our message. Oh, no, no, no. We're going to call it secret plans. I don't know. Bomb the allies. And then we're going to pass into our function our secret plans. So this is going to be encoded. And then we're going to just do 2 console logs so we can see them one above the other. Console log. This is going to be message secret plans. So now when I run this, we should see, oh, what happens? Okay, so the Enigma machine didn't take spaces. So I didn't handle the spaces. I need to get rid of those spaces. Let's see what happens if I run it, because I don't think I took care of that. Bomb the allies. So I don't know what's happening with those spaces. Let's try and get rid of those spaces. How many characters do we have? Bomb is B, what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4 letters. 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, that's weird. So let's first get rid of all the spaces. So let's split it at the spaces. I know, but that's going to give us multiple arrays. Okay, let's say if element does not equal an empty space, return. Oops. Oh, I made a mess. Oh wait, I need this, and then I need this up here, and then this is going to go back here. So if it's not an empty space at the current element, return the wire pairs of that element. Let's run this. Let's copy and paste this real quick. Comment this out. Let's get rid of these spaces. See if we get the same thing. These empty spaces are causing a problem. So let's go back a step. Oh, I got so excited that I was done that I'm rushing now. So the first thing is, let's do this. Let's take the message array and we're going to split it. So now we've got all the characters in a space. Now we're going to do message array no spaces equals message array dot filter. And that's going to take each element. It's going to return it if the element is not equal to an empty space. And then we're going to let message array as numbers equal this message array with no space dot map. Each element becomes the wire pair element, and then this becomes this. Let's see what we get now. Alright, so this is what we get with no spaces. And now let's put the spaces back in and see what we get. The same thing. Alright, so now our answer is independent of spaces. So let's put some more spaces in. See what we get now. Same thing. Cool. So Let's clean this up a bit because it's a little messy. I'm going to go back up here. Well, first let's get rid of these console logs. Actually, let me leave them. I might need them later because I'm going to be doing more. There's going to be a part 4. Now that we've encoded our message, we're going to need to decode our message on the other side. So let me go back. What did I do? So this is this. I'm going to just chain all this stuff. So I'm going to do message array equals message dot split, and then delete that. Now dot filter, and now I'm going to delete that, and I'm going to do dot map. And then now this message array is what we need to put into the rest of the function. Let me run it again just to make sure I did it correctly. I did. All right. So let's make a new message here. Well, let's get rid of all this. This is a message encoded by the JavaScript Enigma Machine. Oh, I'm curious about capital letters. I might have to do a .2 lowercase. I don't know what that's going to do, but let's check it out. So here's our Enigma message right there. Looks complicated to me. Let me get rid of these capitals because I'm surprised that it would work having not handled that. Maybe that's why we had a different number of characters. Yeah, we get a totally different thing here. So if that's the case, I'm going to have to do a .2 lowercase. So where is our message .2 lowercase dot split. So let's run it now. So this is our message with a .2 lowercase. Testing, testing, testing. Let's put the capitals back in, coded by the JavaScript Enigma Machine. Did we get the same string out? Yes, we did. It's done. The Enigma Machine works. I'm very happy. If you like this series of videos, please subscribe to Code Everest. That would be amazing. Stay tuned for part 4 of the Enigma Machine, where I write another function. Clicking, clicking. Whoa, 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 whoa. Okay. Where I write another part of the function to decode a message. So in that video, I'm going to set up a function that's going to take this input using the same settings and configurations of the Enigma Machine, and I'm going to have that turn it back into English. All right. Thanks for watching. Bye-bye.